Hi, students. Okay, so today I'm going to be going through your closure assignment. So these are the problems at the end of chapter 5 to see if you're ready for the test. So your link should take you automatically to this closure section. And the problems I'm expecting you to do are 126, 127, 128, 129, and 131. If you can do these on your own successfully, then you can be successful on the test. Okay, so let's start with 126. You have to determine if they're arithmetic, geometric, or neither. So for 126 part A, we start with some negatives and then we go to some positives. If negatives are hard for you, just focus on the positives. So how do I get from 1 to 5? I went up 4, okay? So now we want to test that that's true for all of the pieces. And if I go up 4 again, that brings me to 9. So moving backwards, -3 plus 4 brings me to 1. And -7 plus 4 brings me to -3. So because this is an adding pattern, this is arithmetic. Okay, for part B, we have -64, -16, -4, -1. So if you don't like negatives, there's no way to avoid it on this one, unfortunately. So if I'm working backwards, I can see 1 times 4 is 4. -1 times 4 is -4. -4 times 4 is -16. And -16 times 4 brings me to -64. So if I'm moving from left to right, that means I was multiplying by 1/4. Some students might say I was dividing by 4. That's the same as multiplying by 1/4. So because this is a multiplying pattern, I would say this is a geometric sequence. Okay, let's take a look at part C. Okay, with part C, I have 1, 0, 1, 4, 9. Now these numbers stand out to me right away, but if they don't stand out to you, we can see we went down 1 for the first set, but then up 1. So already we have an issue. If you have an adding pattern or arithmetic sequence, you need to have the same addition over and over and over. Okay, 0 times anything will never get me to a number, so I know that this is not a multiplying pattern. Now, like I said earlier, these numbers did stand out to me as perfect squares. -1 times -1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. That is a pattern, but it's neither arithmetic nor geometric. Okay, these are perfect squares. We'd say neither. Okay, and let me make room at the top for my last one. I thought I could scroll on here. I got to work on it. Okay, so let me make room for part D at the very top. This has 0, then 2, then 4. Okay. So this one's a little tricky. So from 2 to 4, kids might get mixed up. They could say it's +2 or it's -2. But let's test which one remains the same. Okay. So if I did 0 times 2, that would not bring me to 2. Okay, the multiplier would keep me at 0, 0, 0, 0 repeatedly. Okay, so although it looks like it could be either one, this is only an adding pattern. Okay, you have to add 2 each time. This part D is arithmetic. Okay, pause the video. Make sure you understand everything. If you need to do more practice, let me show you where. So here's the answers for 126. And if you need more practice problems, you can click on some of these. Okay, with number 127, I have a calculator out so I can show you exactly how I'm testing if things are arithmetic or geometric. So if you're looking for an adding pattern, you should test with subtraction. Okay, so let's see what that means. So if I do 1 minus 4, 1 minus 4, that tells me I went down 3. So we can test it again. So if I had -2 and I subtract 1, it's -3 again. Okay, so I'm using subtraction to see. So if I'm following this pattern, 4 minus 3 is 1. 1 minus 3 is -2. -2 minus 3 is -5. Okay, so to write an equation for this, since we're seeing it's an adding pattern, this is arithmetic. Arithmetic patterns follow the pattern y equals mx plus b when writing an equation. And so for this, we need an m, which in this case, we're moving by -3. And then we need a b. This is your move or change. And this is your 0th term. Okay, so it's where you start. So some kids are going to accidentally think 4 is where we started, but you have to move your table up to the 0th term. So if I went backwards one more time, I can see I started at 7. So that's my starting point. Okay, So how do I see this in another way? 7 is my starting term. The next one is 7, and we're bringing in a -3. The next one is 7 plus a -3 plus a -3. So 2 of the -3s, because every time we're going to subtract 3 again. For the third term, we're going to have 7 minus 3 minus 3 minus 3. So we're minusing 3 this many times. So in the first term, we minus 3 0 times. In the 0th term, we minus 3 0 times. In the first term, we subtracted 3 1 time. In the second term, we subtracted 3 twice, and so on and so forth. So this means you start with 7, and then you minus 3 some amount of times, depending on what term number you're looking for. Okay, and then for the next part, part B, okay, if I'm looking for an adding pattern, I could subtract. So 7.2 minus 6 is 1.2. And let's test it again. So 8.64 minus 7.2. And here I have an issue. These are not matching patterns. Okay, I didn't add the same amount both times. So I can already see this is not arithmetic. So I'm going to go back to the drawing board and try geometric. Okay, with geometric, I'm going to test multiplying by using division. So let's try 8.64 divided by 7.2. That means this was a multiplier of 1.2. Let's test it again. 7.2 divided by 6. That was another multiplier of 1.2. So since we're multiplying over and over, this is a geometric pattern. And it didn't ask us to write the equation, but the 0th term here, let's see, we would have to do 6 divided by 1.2 because I'm going backwards. That would be 5. So in this case, we started with 5, and then I multiplied by 1.2, then I multiplied by 1.2 again. So I'm going to keep multiplying by 1.2 some amount of times. Okay, when I was doing repeated addition, I ended up using multiplication. But now that I'm doing repeated multiplication, I end up using exponents. Okay, in the directions and on the test, you will not have to write an equation for part B. I just wanted to show you a little look ahead. But you will have to be responsible for writing the equation for arithmetic sequence. Again, scroll down. You can find your answers. And then if you need more practice, you click over here and try some more problems. All right, when we get to 128, this is a throwback to a skill we've been practicing since August. Probably looks familiar from middle school. It's solving equations. Now, of course, these are much harder than what you would have seen in middle school. So let's try these one at a time. Okay, when we're on 128A, I see numbers on the outside of parentheses. That to me is an indicator that I'm going to have to use the distributive property, which means multiply this 3 to everything inside the parentheses. So 3 times 2x is 6x. 3 times -1 is -3. Everything else just comes to the next step. Okay. Next, I see some like terms on the left-hand side. Although -3 is also a constant, since it's on the other side of the equal sign, they're not combining like terms. You'll have to use inverse operations. So on the left-hand side, if I owe you 3 but I pay you 12, I just gave you 9 bonus dollars. Everything on the right has remained the same. At this point, it's our goal to get all the x's on one side and all the numbers on the opposite side. You have 4 choices here, 4 correct answers for the next step. Me personally, this is not a rule you have to follow, but I like to move my x's and I like to move my smallest x first. So to get rid of a positive 4x, I'm going to minus 4x on both sides. On the left-hand side, 2 x's remain. And on the right-hand side, I just have -3. So now that all my x's are on the left, I'm going to try and get all my constants to the right. So to get rid of a positive 9, I subtract 9. I'm left with 2x equals -12. To get rid of a 2 times x, I divide by 2, so that this just remains with x, and it's equal to -6. Okay, a lot of work with distributing on this one. All right, with part B, I can see that I have fractions. Okay, fractions just mean divide. They're not as scary as they look. So to get rid of a divide by 7 and a divide by 7, well, that's nice that they're the same. I can just multiply every single piece by 7. Got to do it to everything to keep it equivalent. So here, a times by 7 and divide by 7 cancel. I just have 3x plus 2 equals 14. Because remember, we're multiplying every piece by 7. Now this is much easier. It's just a 2-step equation from here. All of my x's are on the left, so I have to move my constants. To get rid of a plus 2, I subtract 2. And now I know that 3x is equal to 12. When I divide by the coefficient, I'm left with x equals 4. All right, with part C, we have fractions on both sides of the equation. We call that a proportion. Now, we can use the same mentality and multiply both sides by x to get rid of this denominator, and multiply both sides by 5 to get rid of this denominator. But a different way of showing that is what some kids call the butterfly method, and they show that they're multiplying across. Okay, so technically, if I was multiplying both sides by 5, this side would cancel. I would just be multiplying everything on the left by 5. And if I multiply everything by x, the left-hand side would cancel, and I'm just multiplying this side by x. So that's where this is derived from. So on the left-hand side, I have to multiply 5 by everything in this numerator. So 5 times x and 5 times negative 3. 5 times x is 5x. 5 times negative 3 is negative 15. And 3 times x is 3x. So now I have an easier equation to solve. I have x's on both sides, and all of my constants are on the left. So if all of my constants are on the left, my goal is to get all my variables to the right. So to get rid of a positive 5x, I'm minus 5x on both sides. Now I have negative 15 is equal to negative 2x. And now when I divide both sides by negative 2, I have 7.5 equals x. Okay, it is a decimal, but that's not illegal. You can have a decimal. All right, now this question is a throwback to chapter 3 where we learned how to multiply binomials times binomials. When I have one piece on the outside of the parentheses, this is the distributive property. I can do this just by multiplying 4x by everything on the inside. 4x times x is 4x squared. 4x times negative 2 is negative 8x. But on the right-hand side, I have 2 pieces times 2 pieces. Okay, when you see something like this, we typically make a 2 by 2 area model. On one side, we describe the length, and on the other, we describe the width. And now it's our goal to find the area of this. So 2x times 2x is 4x squared. 2x times 1 is 2x. Negative 3 times 2x is negative 6x. Negative 3 times 1 is negative 3. So when you combine like terms, the total area is 4x squared. Oh, I don't know why that came out so crazy. 4x squared. You can combine your like terms. Negative 6 plus 2. If I owed you 6 and I paid you 2, I still owe you 4x's. And then minus 3 has no match. Okay, I notice I have x squared terms on both sides. So to get rid of a positive 4x, I'm going to minus 4x squared. And what's so nice about that is it canceled out our x squared terms on both sides. Makes this a lot less complicated. You'll learn how to solve things with x squareds later. Okay, so now I have x's on the left and x's on the right. It's my goal to get all the x's on one side. So since all my constants are already on the right, I'm going to move all my x's to the left. To get rid of a negative 4x, I add 4x. If I owed you 8 and I just paid you 4, I still owe you 4x's. And this is equal to negative 3. Now I divide both sides by negative 4. A negative divided by a negative is a positive. If you turn this into a decimal, I'll accept that too. Either a fraction or a decimal for this one. Again, these were really tricky. Okay, so make sure you know how to solve equations. Here's your answers to check. And then again, if you need more practice, you can click here. Okay, moving right along to 5.129. These are all questions asking you to write an equation of a line, which we learned in chapter 2, but they've gotten trickier since then, or we've tried new methods, so let's test out each one. Okay, so for part A, it says a line with a slope of 4, so slope is m, and a y-intercept, that's b, of negative 6. Okay, what's so nice about this is I can just plug into y equals mx plus b. Okay, I can say y equals 4x minus 6. No real work to be done here. They gave us everything we needed because whenever we use this equation, our final answer should have an m and a b. And those were the two things given to us. Okay, part B. A line with a slope of 3/2, and it passes through the point 5, 7. This ordered pair is considered XY ordered pair. So what I have now is an M, an X, and a Y. So we have a Y, M, X, but I don't have a B. So for my final answer, I'm going to have to find a B. So let me start by using Y equals MX plus B. I use my ordered pair for the X and the Y. So the Y is 7. The M is 3/2. The X is 5. And I'm adding B. Okay. Next, I'm going to say 7 equals 15 over 2. So I multiply 5 over 1 times 3 over 2. If you like decimals better, you can change 15 over 2 to 7.5. And the last goal here is to get b by itself. So I'm going to minus 7.5. That leaves me with a negative half for my B. So for my final answer, I use this M and this B, and I plug it in. Y equals M X. Now you could put minus a half or minus 0.5. Okay, that came from my M and my B being combined. M was given, B we found. Okay, with parts C and D, we have to rely back on our answer from part B, so I just added that to the top as important information. Okay, for part C, you need to talk about parallel lines. Parallel lines should have the same slope. Okay, so if part C, you want to be parallel to part B, then you definitely need to use the same slope. Okay, so y equals 3 halves x, and then it doesn't tell us any other specifics. So it could have any y-intercept you like, +1, +2, +3, +4. You don't have to limit yourself to integers. You can have negative 0.1402, anything you like. This b can be any number, but you have to have the same slope as what we saw in the previous question. Okay, for part D, you need to be perpendicular. Perpendicular lines have opposite reciprocal slopes. Opposite means one's positive, one's negative. Reciprocal means you go from A over B to B over A, like a flip-flop. So if our old slope was 3 over 2, then our perpendicular slope should be negative 2 over 3. Okay, overall this one was positive, so overall this one is negative. You don't have to worry about flipping each number individually, because if you made the 3 negative and the 2 negative, a negative over a negative would be a positive. You'd actually be back to where you started. So overall, if this was positive, this one needs to be negative. So now we know we'll be perpendicular, but it has to pass through the origin. Okay, if you're passing through the origin, that means that's your y-intercept, okay, because you're touching the y-axis right here at 0. So now I know my b is 0. That's enough to plug into our equation. Y equals m x, and you don't have to write +0, plus b. Let's check our answers, and you might need more practice with these, okay? Oh, I didn't read the directions. Okay, we had to give multiple representations. So go back and provide graphs for these or a table or something so you can show how they grow. All right, last problem to prepare you for the test is 131. So for 131, this is a throwback to chapter 4. Okay, Mary notices that sales of fresh fruit cups seem to vary widely from day to day. This is a problem because preparing too many cups is a result in wasted fruit, and making too few results in lost sales. She decides that the daily weather may have a strong association with the demand. Mary chooses 12 days at random from the last semester and pairs each day's high temperature with the number of fresh fruit cups sold each day. So we have a column of temperature and a column of number of cups. To analyze this data, we're going to have to go to Desmos. So let me see what I got. As a refresher, you press plus sign, then table to enter your data. I have it entered here, and then we can see it if we just scroll out. So we have some bigger numbers here. Here's our graph, and then I'm going to show the line of best fit. Okay, let me split my screen so we can see all the questions. Okay, so for A, create a linear model for this data by determining the least squared regressions line, sketch and graph the least squared regressions line. So here it is on Desmos. I'm not going to make you recreate that on a test because I can see it here on your screen. What you do need to know is what is the equation of the least squared regression line. You can find that here. The equation is 1.5, that's your slope. X plus about 8 is your y-intercept. You can see we touch here at about 8. Okay, is it a linear model appropriate? This looks to be a linear growth pattern, follows the straight line pretty well. You will never have to create a residual plot. So although the directions say that, I'm not going to require that on a test. Part C, compute the correlation coefficient and R squared. We're going to compute the correlation coefficient, R. So here you can see R and R squared. Okay, we're talking about R. R is 0.9. So that means it's really strong, positive. Okay, because it's a positive number, I can see that the slope is positive. Ooh. And then because it's 0.9 and it's really close to 0.1, that means everything's really close to the line. So we don't have much spread. Okay, so when it says compute it, you get your answer from here. When it says interpret it, you should say something like it is a strong, positive linear correlation, something like that. Okay. Part D. Oh, here we go. Okay, make sure you describe the form. It is linear. Provide numerical values for direction. I know that it is positive because I have a positive slope, 1.5. So direction is positive because the slope is positive. And then the strength is strong because R value is close to 1 or -1. And then I don't see any outliers. Nothing's really standing out from the crowd. Like if you had a point over here, that may be an outlier. Part E. If Mary wanted to be reasonably certain of not running out of fresh fruit cups on a day forecasted to be 90, how many should she prepare? Okay, so 90 degrees. Degrees was our X value. So I want to know what happens when the X or degrees is 90. So let me type that in here. All right, so when I type in X equals 90, I see this red line, and I want to know where it meets my least squared regression line. So when 90 is the temperature, then we can expect to have 146 fruit cups be sold. So let's take a look at our answers for 131. Make sure you've written something down. Okay, here's your answers. And again, if you need more help, there is the more practice section here. Okay, use this to make your cheat sheet for the test and practice, practice, practice.